Hi, I'm going to do something I normally don't do for this course, and I'm going to record lecture videos for parts of Chapter 2. And I'm doing that because this is the chapter that most students have the most problems with. And so I'm going to go through the most important concepts of the chapter. I encourage you to look at these videos as well as the other supplementary videos that you can find on Canvas. So the first thing I want to talk about is describing sets and some basic vocabulary and some basic symbols. A set is what is simply a group or a collection of objects. Now in math, those are often numbers, but they could be anything, and we're going to give examples that aren't numbers for the most part in this video. The objects in a set are called the set's elements or its members. To name a set, we use capital letters. When describing a set, when describing what are the elements are put in braces and they are separated with commas. Math is really picky about some things, and it's picky for reasons that are actually good reasons. One reason it's picky is because if we use a certain symbol, someone who knows math knows what that symbol means. And so when we're talking about sets, we have to use those curly braces. Do not use parentheses instead. If you use parentheses, it will be wrong. Here are some examples. Set A is the set of US states beginning with the letter I. And so the members of set A, or the elements of set A, are Idaho, Illinois, Indiana, and Iowa. Notice I don't have the word and in here, even though when I read this, I'm going to include the word and. Notice that each element of the set is separated with a comma, and notice that the set is put in braces, not parentheses. Let's say set B is the set of US states that border the Mississippi River. So set B would be Arkansas, Illinois, Iowa, Kentucky, Louisiana, Minnesota, Mississippi, Missouri, Tennessee, and Wisconsin. Again, although I say and when I read that list, we don't write and in the set. When listing alphabetical elements, a really good practice is to alphabetize your entries, like I believe I did in set B. That's important, among other things that will help me when I see it grade it more quickly and not miss something. When listing numbers, you want to put the numbers in order from smallest to largest. Is it wrong if you don't do that? No. However, it will just make it a little more confusing and it will take longer to grade potentially. Now those previous examples are in what's called listing notation or roster notation. And in listing or roster notation, you simply list all the elements in a set in braces with commas between each element. This is the most common notation we're going to use in this course. Please be aware that there are other notations out there. The most common other notation that's used in math is called set builder notation. This is more commonly used for longer sets where we don't want to list a whole bunch of things. You would probably not want to list, if you had a set U that was the 50 United States, you would not want to list all 50 states. So we use what's called set builder notation. And we always start a set with a capital letter. We usually avoid letters like O and I because they look like 0 and 1. So we start off by saying this is set D is equal to the set. That's what this brace tells us. This opening brace tells us we're talking about a set of all elements X. X here is just a variable, and it's the variable we use most often, but you could put any letter you wanted here. You could have it as A or B or C or D or E or F. Again, we typically don't use O. We sometimes don't use I either for other reasons. But X is the most common, but you could have any letter here, any letter, and it's always going to be lowercase. So the set of all elements X, such that, that's what this vertical bar is read, such that X is an element of the natural numbers. We're going to talk about what that symbol means in a little bit. The natural numbers are the counting numbers. They are the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, on into infinity. And X is greater than 10 and less than or equal to 15. So if I were writing this same set in roster notation, I would write it as capital D equals, and then my braces. And so notice, x is greater than 10. So 10 is not part of this set. But 11 is, because 11 is bigger than 10. 11, 12, 13, 14. And then it says x is less than or equal to 15. So 15 is part of the set as well. So in roster notation, it would look like this. Here's a couple of more examples of set builder notation. Set A is the set of all elements x, such that x is an American state that begins with I. Set B is the set of all elements x, such that x is a state that borders the Mississippi River. Again, for your homework, you are going to be working with roster notation for the most part, maybe exclusively, but I want you to be aware of this other set builder notation. Sets can be equivalent if they have the same cardinality, and that means the same number of unique elements in a set. Two sets are equal if they have the same cardinality and they have the exact same elements. All equal sets are also equivalent, but not all equivalent sets are equal. Here are examples. If we said that set Q consists of the numbers 1, 2, 3, 4, and set R consists of the letters E, F, G, H, these sets are equivalent because they both have 4 unique elements. So these are equivalent sets. They are not equal because the elements aren't the same. Here's another example. Set C contains the elements 1, 2, 2, 3, 4, 4, 5. Set D contains the elements 5, 4, 3, 2, 1. These sets are equivalent and equal. Can you tell why? Pause the video and think about it. These sets both have the same number of unique elements. Both of them have 5 elements. Because remember, the elements are unique. So if a number is in there more than once, or if a letter were in there more than once, or if a symbol were in there more than once, we only count it once. So we have a 1, we have 2 2s, we only count it once. We have 3, we have 2 4s, we only count them once. We have a 5. There are 5 unique elements in this set. There are also 5 unique elements in this set. That means they're equivalent. They both have a cardinality of 5. The elements are also identical. In each set, there's an element 1, there's an element 2, there's an element 3, there's an element 4, there's an element 5. It doesn't matter what order the elements are in. It doesn't matter if they're repeated. As long as you have the exact same elements in both sets, those sets are equal. Now, normally when we are making our own sets, we won't repeat elements like we've done in set C. And we'll normally write them in increasing order like we've done in set C. But that's just a convention. It doesn't change the contents of the set. There are actually several symbols you need. The first few are going to be introduced in this video. More will be coming. This symbol means that something is an element or a member of a set. So for example, we have the set W is the set of all elements X, such that X is a state that borders a Great Lake. Any state that borders a Great Lake is a member of this set. So we could write Minnesota is an element of W. This means that Minnesota is a member of set W. So is Wisconsin, so is Michigan, so is Pennsylvania, so is Ohio, so is New York, for example. That same symbol with a diagonal line through it means is not an element of. And so with that same set W, we would say that Iowa is not an element of W because Iowa does not border a Great Lake. I find it easy to remember that this symbol means element because the symbol looks a lot like a capital E. One special type of set is called the universal set, and it's always represented by the capital letter U for universal. The universal set contains all elements being considered. So in math, we often will say something like the universal set is all natural numbers. So that would be starting at 1 and going on forever. We might say the universal set is the set of all integers, which will be going from counting from 0, 1, 2, 3, 4, 5 forever, and then counting back from 0, -1, -2, -3, -4 forever. So we might say the universal set in a social studies lesson is the set of all countries of the world. We might say universal set in science is the set of all planets in the solar system. The universal set contains all of the elements, all of the members we're being considered. For example, we might have the universal set that is set U, such that contains all elements X, such that X is a student at the University of Iowa. That's the universal set. Now notice, this isn't all the people in the world, this isn't all the people in Iowa, this isn't all the people at universities. It's specific to this group. All people enrolled at the University of Iowa as a student. And then we have set E. Set E consists of all elements X, such that X is an elementary education major at the University of Iowa. So this is one group within that bigger group. And we can represent this relationship and all set relationships with special drawings called Venn diagrams. Here's an example of this. So a Venn diagram by convention is usually a rectangle. And when we're talking about the universal set, we label that with a capital U. And then inside the rectangle, the sets that we have are by convention represented with circles or ovals if you are not a good drawer, like I am not a good drawer. And then the letter of those sets are either in the circle or right next to the circle. So here we have our universal set, every student at the University of Iowa. Inside the circle, elementary education majors there. A set's complement, notice this is complement with an E. This is not, complement with an I is when you compliment somebody on, oh, I like your shoes. Complement with an I. Complement with an E means it completes something or it goes with something, like peanut butter complements jelly. The complement of a set are the elements that are in the universal set but aren't in the set you're considering. So the complement of set E would be students at the University of Iowa who aren't elementary education majors. Maybe they're history majors, maybe they're psychology majors, maybe they're art majors, maybe they're undeclared majors. There are unfortunately several ways to write this, which is confusing because if you see some of the other videos posted, you're going to see more than one notation. Your textbook uses this format, which is the name of the set, the letter of the set, with a horizontal line segment above it. We read this as the complement of E, or E complement sometimes. Other textbooks use the notation E with an apostrophe after. This is actually a prime symbol in math. Or an E with a superscript lowercase c for complement after it. So you might see this. This is really commonly used. You might sometimes see this as well. The reason why not every textbook agrees on the way to write this is because some of these mean different things. So that horizontal bar in statistics means you're finding the mean. This prime symbol in calculus means you are differentiating. So there are reasons why in certain math books one is chosen over the other. So we will typically use this, but be aware that you're going to see these others in some of the videos that you might run across online. So here's the same Venn diagram. Now we've included E complement. So we have the same universal set, all students at the University of Iowa, the same set E, all elementary education majors, but now the complement of E, all students who are not elementary education majors. Another special set is called the empty set. If a set has no members, it's called the empty set. For example, set Q is the set of all elements X, such that X is a U.S. state whose name begins with the letter Q. There are no states whose name starts with Q, so the set is empty. The empty set is also called the null set. The symbol for the empty set is a circle with a diagonal line through it. It looks a little bit like zeros sometimes look like on computer keyboards. It is not a zero. And that's going to be important for this class especially. If you are in the habit of writing your zeros with a line through them to differentiate them from capital O's, don't do that for this class, especially for this section of the class. Yeah. Now, this symbol isn't found on computer keyboards. You have to go and insert symbol or do something else to get it in there. So what we typically use is we use braces with nothing inside them to represent the empty set. So when I type this, I made my opening brace and then I hit the space bar once and then the closing brace. Using our previous example, for example, if for some reason at the University of Iowa, if there were no elementary education majors, then that would be an empty set or a null set. And then the last big concept I want to talk about is cardinality. A cardinal number is a number that answers the question, how many? And cardinal numbers are really the main way that people use numbers traditionally. That's when we answer, how many cookies do you have? How many pencils in your backpack? How many books in your bookshelf? How many contacts in your phone? When a number answers the question, how many, that's called a cardinal number. And in set theory, the cardinal number is the number of unique items in a set. The empty set has cardinality 0 because it has no items in it. We always represent cardinality with an italicized lowercase n, followed by, in parentheses, the name of the set. So this means the cardinality of set A. In other words, how many unique items or elements are in set A. Here we have two sets with numbers. Set F contains the elements 7, 8, 8, 8, and set G contains the elements 8, 9, 10, 10, 10, 10, 11. What is the cardinality of F? What is the cardinality of G? Pause and try to answer those two questions. What is the cardinality of F? The cardinality of F equals 2 because there are two unique elements. It doesn't matter that the 8 has been repeated. We have one element, that's a 7. We have a second element, that's an 8. Cardinality 2. What is the cardinality of G? The cardinality of G is 4 because we have 4 unique elements. We have an 8, a 9, a 10, and an 11. It doesn't matter the 10 has been repeated. So to review this video, always put elements in braces, never parentheses. Please don't put, however, answers to things like a cardinality problem in braces. That answer is a number, not a set. Sets are equivalent if they have the same cardinality. Sets are equal if they have the exact same elements. Those sets will also always be equivalent. The empty set has cardinality of 0. And then the universal set is always represented with a capital U. In the next video, we will continue with this section, and we're going to talk about subsets.